A special type of integration by parts method is called the cyclic method. It's the third example that I have for 611. We started with integrating natural log of x. That's in the previous video. This is what I call a one and done integration by parts. We made our substitution, we did integration by parts, and we were able to integrate u dv at the end. And this is the tabular method. This is one where we had x cubed and cosine of x, and x cubed eventually went away, but cosine of x does not. And so you wind up having to do integration by parts several times, and one way to organize that work is with the tabular method. This third example is what I call cyclic. This is one where both of our functions are not going to go away with either integration or differentiation. So our two functions are sine of x and e to the x, well, e to the 2x. And so if I go through Lipit, logs, inverse trig, polynomial, exponential, I'm going to use e to the 2x as my u. So I'm going to go through that and I say u is equal to e to the 2x. That means dv is everything else. And I'm going to take a derivative of this. I'm going to get e to the 2x, and then remembering the chain rule, 2 e to the 2x. And I'm going to take an antiderivative of this, so that would be negative cosine of x. And then I'm going to apply my formula. So I have the integral of sine x e to the 2x dx is equal to u times v minus v du. It's minus a negative, so I'm going to make that plus. And then I notice that I still am going to do integration by parts because nothing has gone away. And this is not a good candidate for tabular method because nothing will ever go away. I'll never be able to take derivatives down to 0, which is what I need for tabular. I am going to pull that 2 out in front, so I have negative e to the 2x cosine x plus 2. So I'm just going to do it again. So I'm going to say, well, u is equal to e to the 2x. dv is everything else. So du is 2e to the 2x times dx, and v is sine of x. And so I have the integral of sine of x e to the 2x dx is equal to negative e to the 2x cosine x plus 2 times u times v minus the integral of v du. Oops, I forgot the sign.
Thanks, Leo.
And at this point, you might be panicking because you're thinking, well, I was trying to do the integral of sine x e to the 2x, and I wound up with sine x e to the 2x again. And so what am I going to do? And here's where the insight comes from. You say, well, I'm going to say that I am trying to find this integral. So I'm going to make that into a variable. I'm going to solve for that integral. So I could keep going, but there's no reason to believe that the integral would ever go away. But what if I do a little substitution for that integral? So I say I is equal to negative e to the 2x cosine x plus, I'm going to distribute this 2e to the 2x sine x minus 2 times another 2 times I. So I have a bunch of i's. I have 4i here. I'm going to add 4i to both sides. So I get 5i is equal to negative e to the 2x cosine x plus 2e to the 2x, oh, I forgot my x, sine of x. And so that integral is done. I know what that integral is. I just need to throw a plus c after it and divide by 5. So I is equal to negative 1/5 e to the 2x cosine of x plus 2/5 e to the 2x sine of x plus c. I have solved for the integral I was trying to solve for. I call it cyclic because we cycled back and we wound up with the same integral that we were trying to solve for, so we just algebraically solve for it rather than do it directly. That is the third type of integration by parts problem. Thank you so much. Bye.